I'm going to explain this topic. So for your CT1, you'll be having the prediction techniques and the clustering techniques. So whatever prediction techniques I have explained, like linear regression, multiple regression, and that regression tree, followed by clustering techniques like k-means, k-meanoids, and this DB scan, and the hierarchical clustering. So I think altogether there are seven topics I've explained under the prediction and clustering. So you'll be having these 7 topics for your CT1 pattern. I will let you know towards the end of like just when your CT1 is announced. Before that, I will let you know. So this is this technique is called as DB scan. It's one of the clustering technique under the density based clustering category. So the DB scan full form is density based spatial clustering of applications with noise. So this density based clustering will try to create clusters as dense regions of objects. So wherever the data density is more, it will be formed into clusters, and the shape of the clusters will be arbitrary. It will not be uniform, it will be non-uniform. And the low density regions represents the noise. So some points will not be may not be included in any of the clusters. So those points will be called as the noise points. So this DB scan clustering technique, which comes under this density based method, is specifically designed where the applications will have a lot of noisy data. Noisy data is like the data with data which consists of more irrelevant data. So before explaining the DB scan technique, the algorithm with an example, before that I wish to explain some terminologies which you must understand before proceeding to the problem. So the first terminology, like there are 3 types of data points associated with this DB scan. So the set of data points that are considered under this algorithm will be categorized as core points, border points, and noise points. So in order to understand these 3 type of points, you must understand this epsilon and min points. Epsilon is some type of distance, something like a Euclidean distance or Manhattan distance. It is some distance measure. And min points are the number of data points, number of neighboring data points. So these two. So now we have to relate this epsilon and min points with all these 3 category of points. So core point is the one. So if you take some data as the core point and you call that data point as a core point, if you draw a circle of radius epsilon. So you are drawing a circle of radius epsilon, and you have min point number of points within that radius. Say for example, min point is equal to 3, and say radius is equal to 2, that is the epsilon is equal to 2. So you can call some data point, like you may have a number of data points to be clustered. So you take any data point, and if you want to label it as a core point, then you have to draw a circle of radius epsilon. So in this case, it is 2. And you should have at least min point number of points inside that circle. So there should be at least 3 points inside that circle. Then you can call this point as a core point. So that is the definition for the core point. And a border point is something which will not have min point number of neighbors inside the epsilon radius, but it will share the neighborhood with a, but when you draw a circle with epsilon radius, it will be inside the radius of another core point. So if you have a core point here, and if you draw a circle here, and if there is some border point, then that border point, if you draw the circle, so that circle with radius epsilon will intersect with this circle, like it will share the neighborhood with the core point. But if you see the number of points within this radius, it will be less than min points. Only for the core point, it will have greater than or equal to min point number of points inside the epsilon radius. But for the border point, it will not have the min point number of points inside the epsilon radius, but it will share the neighborhood with the core point. And any point which does not fall under the core point or border point will be called as the noise point. So these are some of the terminologies that will be associated with the DBSCAN clustering algorithm. Epsilon, which is the radius of the circle that is going to be drawn, and the min points will be the minimum number of points in that epsilon radius to make the data point as a core point. And the core point is the data point with which if we draw a circle with radius epsilon, there will be at least min points number of data points within that circle. And border points are those which will not have min point number of data points inside the epsilon radius, but they will share their neighborhood with the core point, with any one core point at least. And any data point that does not fall under core point or border point will be called as the noise point. So with these terminologies, let me explain the algorithm for this DBSCAN. So the objective of the DBSCAN is to take all the data points and label those data points as either core point or border point or noise point. So that will be the first step. So based on the distance measure, we calculate the distance, and based on the min points, that criteria, we label it as core point or border point or noise point. So that is the first step. And then we will separate the core points from the border points, and border points sometimes might share the neighborhood with one or more core points. So in that case, the border points is supposed to be assigned to one of the clusters, one of its clusters with which it shares the neighborhood. So the a data point which is a border point may share the neighborhood with two core points. So you have to decide with which core point it is actually going to belong to, means with inside which cluster it is actually going to belong to. That dilemma has to be resolved for the border point, and the remaining points will be the noise points. So these noise points can be either ignored. So generally noise points will not be put into any cluster, they will be ignored, or they can be kept as such for making some further processing related to the data set. So when all these processes are done, then the algorithm will terminate. So first step is to label the data points as core, border, or noise, and then the border points dilemma has to be resolved. If border points share the neighborhood with multiple core points, then it has to be decided to which core point it has to belong to, and then the noise points are generally ignored. So these are the three major steps involved in the DBSCAN algorithm. So let me explain this DBSCAN clustering algorithm with an example data. So a data set is considered here for example. So here there are some 6 points, A, B, C, D, E, F. Say they have two parameters, x1 and x2. So here some data points are given here. Now you are asked to perform the clustering with the DBSCAN. So in order to perform the clustering with the DBSCAN, the first step is to label them as core, border, or noise points. And the inputs given for this problem is that min points is equal to 3, epsilon value is equal to 1.5, and the epsilon objective objective function. The epsilon distance is going to be calculated using the Euclidean distance. So Euclidean distance I have already explained in the last class. This is the formula for the Euclidean distance, which I have already used in yesterday's class for calculating the distance between points in the hierarchical clustering method. So distance between 2 points x comma y and a comma b is equal to square root of x minus a the whole square plus x minus b the whole square. So actually it's y minus b the whole square. X minus a the whole square plus y minus b the whole square. So typo is there. So whenever you refer this formula, don't be like I try to change it here before. Yeah, I've already shared this PDF. Anyway, I'll try to update this and share it again. So if the Euclidean distance is given as the objective function for calculating the distance. So now the next step. So the first step is to label the points as core, border, or noise. So here there are 6 points: A, B, C, D, E, and F. So what we try to do is we try to calculate the distance between each pair of points. That is, for the data point A, we calculate the distance between A to B, A to C, A to D, A to E, and A to F. That is what is done here. Distance between AB, AC, AD, AE, and AF. So considering these two pair of points, applying in the Euclidean distance formula, you will be getting this distance value. So similarly, all these values, this entire problem will be calculated. Now we have this data. We have this distance data. That is the distance between A with every other point B, C, D, E, and F. So with this data, we can label this data as either core or border or noise point. So the condition for the core point is that within a distance of 1.5, there should be 3 points. So you can observe that the data point B is 0.71 away from A, and data point C is 5.66 away from A, and D is 3.61 away from A, and E is 4.24 distance away from A, and F is 3.2 distance away from A. Now among these points, which are the points, or which is the point that is less than or equal to 1.5 distance away from A? So you can observe that very clearly only one point is actually less than 1.5. So with this, you can conclude that this is not a core point, but you cannot decide whether it is a noise point or a border point. So in order to understand whether it is a noise point or a border point, you need to first identify all the core points. So you have to keep your decision pending until all the core points are discovered. So it could either be a noise point or it could be a border point. If it shares the neighborhood with a core point, then you can label it as border point. If it does not share the neighborhood with any core point, then you can label it as a noise point. So this is how you are supposed to do, but I will directly jump to the core points first, and first let us discover the core points. So the distance between E and the remaining points A, B, C, D, and F are calculated. So these are the distance values. And as per the definition of the core point, you can see that there are 3 points. So 3 points plus this point E. So with E as center, if you draw a circle with radius 1.5, you will be getting these 3 points as well as E, which are lying inside the circle within a radius of 1.5. So these points are more than 1.5 away from E, so it will not be considered. So only these 3 points will be considered in addition to the point, the actual data point itself. So 4 data points are lying within the epsilon radius. So E can be called as a core point. Similarly, F. So in F, again you have 2 points plus this F, because from F, if you draw a circle, say this is F, if you draw a circle with 1.5, you will have F, and in addition to F, you may have two other points less than 1.5 radius. For F, obviously it is going to be 0. F to F is 0, and there are two other points which are less than epsilon radius. So there are total 3 points in the epsilon radius. So this F point can also be called as a core point. And similarly, the D point. So for D point also, you can see that there are 2 plus 1, 3 points within the 1.5 epsilon radius. So D can also be called as a core point. So overall, there are 3 core points. That is, E is a core point, D is a core point, and F is a core point. Now, when it comes to A, C, and B, so for A, there is only 1 point. So 1 plus 1, only 2 points within the epsilon distance. And if you observe for C, there is only 1 plus 1. So 2 point within the epsilon distance. And similarly for B also, only A and B will be within the epsilon distance, that is 2. So all these 3 points have only 2 points within the epsilon distance, so they don't have minimum 3 required to be satisfied as core points. Now we have to put them as either border point or noise point. So in order to do that, what we have to check is that whether they share any neighborhood with the core point with a radius of the epsilon value. So if you observe C, C is having some value, less than 1.5. C is having some value less than 1.5. And whether that point is a core point? Yes, E is a core point. So C shares the neighborhood with the core point, say E. So because C falls within the epsilon distance of E, which is a core point. So C can be categorized as border point. Similarly, B. So if you observe B has only one data point, which is less than like B itself plus A, but A is not a core point. So B cannot become a border point. So B will be a noise point. And similarly, A has only one another data point within a distance of 1.5, that is B, and B is not a core point. So A cannot be a border point, it has to be a noise point. So after completing the labeling, we identify that D, E, F are core points, C is a border point, and A and B are noise points. So the solution for this problem is that for this given data set, A and B will be the noise points, and they will be discarded. And the remaining points C, D, E, and F will be forming one single cluster. That is the conclusion of this problem for this given input. So this is the cluster for this given input. When min points and epsilon will change, then the clustering output also will change. So this is the graphical representation for this. So it has been plotted in a XY graph. So you can see that this represents the one single border point, the 3 core points, and the 2 noise points. So there is also possibility that sometimes this C may share the neighborhood with sometimes with two border points. Say D is also a border point, and say if this is 1.24 instead of 2.24, then you have to decide into which cluster it has to belong. So generally it is put into a cluster which is nearer to the core point. So you have to push it into that particular cluster, because since it's a border point for two clusters, you have to put it into any one cluster and resolve the dilemma. So that possibility may also arise. In that case, it has to be put into any one of the cluster, that is the nearest cluster. So this is how the clustering is done using DBSCAN. The first step is to label the points as border, core, or noise. And then second step is that if the border points share neighborhood with more than one core point, then the dilemma has to be resolved. It has to be clustered with only any one core point. And finally, the noise points will be discarded. So that will yield some significant clusters. That will be the output of the DBSCAN. So this is the end of this technique, and the end of syllabus for your CT1. So if you have any doubts, we can discuss now.